Lastly, solids have both a fixed shape and volume.
Today we're going over the summary and review of Unit 1. Chemistry in the modern world is the area of science that works with identifying unknown substances made of matter, investigating their properties and how they interact, combine, and change. And lastly, the use of these processes to form new substances. Matter is any physical material in our universe that has mass and occupies space. This matter has certain properties that allow us to distinguish it from all other matter. One example of a property is color. This matter varies a remarkable amount, but when we break it down to some of the smallest bits, matter is composed of atoms of approximately 100 elements. These atoms form molecules, and the molecules form matter. Small differences in the atomic makeup of molecules can have drastic consequences on our world. One of the fundamental challenges for chemists is how to change molecules in a controlled way to see what the change is to the properties. Studying the changes and properties of matter allows chemists to gain knowledge about this matter and use it to make the world a better place. Innovations in chemistry have improved everything from healthcare to space exploration. There are two main ways matter is classified. The first is what is its physical state, and the second by its composition. The three most basic states of matter are gases, liquids, and solids. Gases have no fixed shape or volume. Liquids do have distinct volumes independent of the container they're in. The volume of water in a glass is the same if you pour it into a dish, and they also conform to their container. Lastly, solids have both a fixed shape and volume. You can also look at the different states of matter on the molecular level. With gases, the molecules or atoms are moving at a high speed, and there is a large relative distance between each. The speed and distance decrease as you go to liquids and solids. Liquids molecules are packed more closely together, but the molecules can move easily, which enables the liquids to be poured. With solids, the molecules are held together by a force, making the molecules immovable unless a greater force is applied. This accounts for solids' rigid structure. Most forms of matter that we encounter on a day-to-day basis are a mixture of many different molecules. The air we breathe is only approximately 20% oxygen. The rest is a mix of a bunch of other gases. The water we bathe in isn't just pure H2O. There are often a mixture of salt ions in it as well. Lastly, the ground we walk on is composed of a vast variety of different elements. However, we can isolate mixtures into pure substances, which is matter that is composed of only one type of molecule or substance. All substances are either composed of elements or compounds on the molecular level. Elements are composed of only one type of atom, and compounds have two or more element atoms. Mixtures can contain more than one type of compound or element. The mixtures that vary in consistency, such as stone, are called heterogeneous mixtures, and mixtures that have a uniform composition, such as air and water, are called homogeneous mixtures or solutions. Every substance on Earth or in our universe has specific and unique properties that allow scientists to differentiate substances from one another. The types of properties are broken down into two categories: physical and chemical. Physical properties can be detected without changing the specific chemical makeup of the substance. Examples include color, odor, density, melting point, and boiling point. Each of these examples include a physical change of the substance in which the appearance might change, but the chemical composition stays the same. Chemical properties can only be detected through changes in the matter and include the reactivity of a substance. These changes are often irreversible, meaning that you now have a new substance. The variations in properties allow science to separate different substances. An everyday example of this is if you've ever added oil to water. Even though both are liquids, they do not mix together because of their differences in solubility. Furthermore, the differences in densities make the oil float on top of the water, allowing for easy separation. Many of the properties of matter are measured quantitatively, meaning with numbers. When these properties are measured, specific units must be included to help scientists accurately compare the measurements. As scientists, we use the prefixes of the metric system as the go-to classification of varying measurements. Furthermore, we adopt the base words of the SI unit system to remain consistent amongst measurements between scientists with mass, length, temperature, time, amount of a substance, and electric current. With measurements, you inherently have limitations on how exact the measurements are. These limitations are a result of human error and instrument limitations. For example, some scales only measure to 1 decimal point, such as 10.4 grams, while others are more accurate and precise, measuring down to multiple decimal points, such as 10.415 grams. These terms of accuracy and precision can be used in the discussions of measurements. Accuracy is the extent of how closely each measurement is to the true value of the measurement. Precision is how closely each measurement is to one another. The classic description of this is with a dartboard. With poor accuracy and precision, the darts are all over the board. With poor accuracy but good precision, the darts are closer together but don't hit the bullseye. With good accuracy and precision, the darts are close together at the bullseye. Since the measurements of matter have distinct units connected with them, it's important to keep track of the type of units for conversions of the numbers. For example, converting 2 pounds to grams. To do this, we employ dimensional analysis. Dimensional analysis is when you multiply or divide numbers with their specific units by conversion factors. In the example of 2 pounds to grams, you multiply the 2 pounds by 453.592 grams per 1 pound to equal 907.184 grams. This can also be done using 2 or more conversion factors. For example, converting 2 tons of water to moles of water. To do this, you multiply the 2 tons by 907,185 grams per 1 ton divided by the 18.02 grams in 1 mole to equal 100,686.5 moles of water. The key behind the dimensional analysis is to make sure that the units cancel out correctly and that you're using correct conversion factors. Thank you so much for spending your valuable time learning and bettering yourself. If you liked the video and want to learn more, please subscribe or check out my website, nocollegeneeded.org. If the subject isn't up yet, please be patient. I'm working on bringing them up as soon as I can. Thank you so much for spending your valuable time learning and bettering yourself. If you like the video and want to learn more, donate, or get tutoring, please check out my website, nocollegeneeded.org. You can use the code NCN for 20% off tutoring and any supplemental materials. If the subject isn't up yet, please be patient. I'm working on bringing them up as soon as I can.